Hi, in this tutorial, Tutorial 5, Section 6, Part 5, I will be coding the menu system items one by one. This section will demonstrate creating and using a new subroutine. Then I will explain new program elements in the menu code blocks as I code them. Additionally, in this tutorial, we will continue utilizing if-then-else constructs to choose which program actions are executed based upon the current status of certain program conditions. Also, I will cover a few more useful tips and discuss implementing some common menu and program conventions. First, we are going to create a generic subroutine in fmain's class file. When we are finished, this subroutine can be used by those menu options that will not be coded at this time. So any of the currently disabled menu options can be re-enabled and set to call this subroutine rather than simply making those menu options unavailable at runtime. It is important to understand that any part of the program can call such a subroutine and use its functionality. However, at this time, this subroutine is designed as an option for those menu choices which will be non-operational at this time. I am going to use this subroutine for some menu entries and simply leave others disabled, but you can choose which menu entries use which program action. In this example, it is entirely up to you. This exercise will give you greater flexibility in the example program and also provide a little more experience creating and using subroutines. Here is the actual program code that we will be adding at this time. I will demonstrate calling subroutines and describe a few more of the basic elements of creating subroutines within a program's class file. In the next program example, I plan to cover more of the fundamentals of subroutines. This is the actual program code contained in this particular subroutine. However, a subroutine can contain any program code and functionality that you need to replicate or access repeatedly. Generally, whenever a programmer begins to notice similar code blocks or functionality within a program, they should consider creating a subroutine which contains the common functionality and then simply call the appropriate subroutine when needed. This code block simply uses the now familiar message function to display a static formatted text message whenever a non-coded but enabled menu entry is selected by a user. Creating a code-accessible subroutine is very simple. At the top of the subroutine is created, named, and defined as to its scope within the program. And a subroutine is closed with the end statement. Everything between those elements is the program code that is executed each time the subroutine is called by another section of the program. And after the subroutine code is executed, the program's execution will then return to the part of the program code which called the subroutine, and resume executing the program code immediately after the code which called the subroutine. The subroutine declaration is the section of code where new subroutines are created and its use is defined. The first element of the subroutine declaration defines the scope of the subroutine. Defining the subroutine to be public means that any element of the program can access or call the subroutine and its functionality. Next is the part of the declaration that tells Gambas that the following code is the start of a subroutine. Then comes the actual name of the subroutine. This name can be used by other parts of the program to call a specific subroutine. You should note that the name of the subroutine is effectively arbitrary. It can be whatever the programmer chooses, with the exceptions that it cannot be a Gambas keyword or standard function, and the name cannot contain spaces. Again, however, underscores can serve the purpose of making the name more readable. The final element of the subroutine declaration are the open and close parentheses. As consistent throughout the Gambas language, this means that data can be passed to the subroutine when it is accessed through code. I will be demonstrating passing data into and out of subroutines in following program example tutorials, where I will describe subroutine structures and how to use them in greater detail. Remember, subroutine code blocks begin with a subroutine declaration and terminate with the end statement. And all of the subroutine's code exists between those two program elements. In this example, the subroutine code will output a message box containing a textually formatted message to the user. This code starts with the message command. And within the message function's parentheses is the text message and formatting commands, tied together with an ampersand. This is the only new code which you haven't seen in prior program examples. This is the Gambas language character string command. It is used to print individual ASCII characters, including screen control characters. In this case, the character string 10 is the screen code for a new line character, which prints a blank line. Then an ampersand concatenation character is used to build the fully formatted text string for the message box. This is followed by the actual message text within quotes, which will be displayed in the message box. So this pop-up message box will display a blank line followed by the text option unavailable at this time. You should note that printing a blank line at the start of the text is being used by me simply because I believe it improves the visual appearance of the displayed message. Now we are going to add a generic subroutine to the fmain class file. This subroutine will display the message that the option is unavailable when certain menu options are selected by a user. This subroutine will be called by those menu options that will be enabled but not coded at this time. But remember, in actuality, any part of the program would be able to call this public subroutine. First, go to the bottom of the fmain class file. The subroutine is to be named option not available, and since it is a public subroutine, enter public space sub space option underscore not underscore available open parentheses close parentheses. This creates a new subroutine in the Gambas program. You can note that Gambas will automatically add the end statement at the bottom of the subroutine for you. Next, between the subroutine declaration and the end statement, enter the single line of basic code, message, open parentheses, CHR $, open parentheses, 10, close parentheses, ampersand, double quote, option space dash space unavailable at this time, double quote, close parentheses. This code will display the subroutine message whenever it is invoked by any other part of the program. After the subroutine has been added, return to the fmain form in the IDE. As an example, I have chosen to call this subroutine whenever the Edit menu's Preferences option is selected by a user. So navigate through the Edit menu and click on the Preferences menu entry. And in the code block that begins Menu Edit Preferences click, add the code option_not_available, open parentheses, close parentheses. This code statement will call the subroutine and run the code within the subroutine to display the option unavailable message box when the Edit menu's Preferences option is selected by a user. Again, remember, any of the enabled menu options can call this subroutine. At this point, however, the only menu item that is currently enabled, which will not be coded in this version of the program, is the Preferences menu item. However, you can simply re-enable any of the disabled menu items and have them call the option unavailable message box rather than having an uncoded menu option visibly disabled at runtime. It is entirely up to you, and I encourage you to try out the possible options. Save the project and run it to try the subroutine. After moving back to the fmain form, we are going to begin coding the various menu options. Now that the overall menu system structure and the generic option unavailable subroutine have been created, I will be coding the various enabled menu options one by one. Also remember, once the fundamental elements of the program's menu have been created in Gambas, you can easily make adjustments to the menu system at any time by relaunching the menu editor within the IDE. The menu editor can not only be used to fix errors, but a programmer can also easily make changes to improve the overall aesthetics or functionality of the menu within the IDE at any time. I will demonstrate making such changes shortly. Now, to return to coding the various menu items. Remember, the new entry in the File menu is simply a path to the New Document option, so the file entry New will not require any actual program code. So first, we will start by coding the File New Document menu entry. Navigate to the New Document entry in the menu and click on it. And in the subroutine that begins File New Document click, add the program code textarea1.text equals ... At this point, this code will simply immediately clear the contents of TextArea1. Later, we will improve this action to make it more user-friendly and user data safe. However, right now, we are simply going to clear the current contents of the text area on tab 3 to effectively create a new text document while the program is running. Next, after returning to the fmain form and the File menu, click the Quit menu option, and in its Click event, add the Gambas command Quit. This command will end the program. Again, return to the fmain form. Since the Edit Preferences menu selection has already been coded and calls the new Option Unavailable subroutine, the next menu item which needs to be coded is the Insert Catchphrase menu option. Select it. Once you have clicked the correct menu entry and are in the Menu Catchphrase code block, add the code textarea1.text equals textarea1.text ampersand double quote Gambas rules double quote. This code will add the new catchphrase text to the end of the current contents of the text area, without deleting what is already displayed. Here you should note that you can enter any text that you would like to be able to insert into the text area from the menu. Just change the text between the double quotes. Here I would suggest placing spaces at the beginning and the end of your text to separate it from what is already within the text document. Next, under the first line, add the program code textarea1.refresh open parens, close parens. Here you should note that the refresh method tells the program to immediately update the contents of the text area. This is necessary due to the fact that Gambas is primarily a user event-driven language, and setting the text property of the text area through code may not trigger a text area user event. So the actual text within the text area may not be updated until another text area user event occurs. Therefore, in the Gambas language, you can use the refresh method to tell a Gambas program to execute an object event and immediately update that object. Go ahead and save the project. The document closing menu entry is coded in a virtually identical manner. So return to the fmain form and select the Insert menu and click the Document Closing menu entry. In this example, I am also using multiple character string blank line characters added to the actual document closing text. I am doing this to better format the visual appearance of the document closing text when it is appended to the end of the current contents of the text area. Here is a quick overview of the code that will insert the document closing message within the text area on tab 3. This code will insert a predefined and formatted text string to the end of the current contents of text area 1. Again, we will be using the character string command to add what are called new line characters, which will place blank lines within the text string. Remember that a character string 10 in a text string causes a text element in the program to immediately move down to the next line of text, and two such new line characters together has the effect of adding a blank line to the text that is being displayed. Again, the code uses ampersand concatenation characters to build the overall text string. Here, this single text string is being appended to the end of the contents of the text area. This text is formatted to properly add text and blank lines to the letter style document closing, which is inserted at the end of the current contents of the text area. And remember, this is just an example, so the actual text within the insert option is arbitrary and can actually contain whatever text or formatting that you choose. Now we need to place the code in the menu items event. So within the insert document closing code block, add the line textarea1.text equals textarea1.text ampersand character string open parens 10 close parens ampersand character string open parens 10 close parens ampersand double quote sincerely double quote ampersand character string open parens 10 close parens ampersand character string open parens 10 close parens ampersand double quote nerd sanity double quote. Additionally, under the first line in the Insert Document Closing subroutine, the Gambas refresh function will again be called by adding the code textarea1.refresh open parens close parens. Again, the refresh method is being used to ensure that when the code from the menu option is selected from the menu by a user, the text area object on tab 3 will immediately be updated with the newly inserted closing text. Remember, sometimes object events may not be called when you expect them to occur, and this can be an issue. Other times, the code may function without any problems. However, the refresh method can be used to call events whenever you experience mysterious instances of those program events failing to occur when you need them to happen. And generally, in programming, I believe it is usually a good idea not to leave anything to chance, especially when there is no appreciable penalty in implementing possibly unnecessary but more robust methods of coding. Now that the insert menus have been coded, go ahead and save your work. Now the program's insert menu can be tested. To test the newest functionality, run the program. The insert menu adds items to the text area on tab 3. So click on tab 3 and enter some text. Then test both insert options. If there is an issue, close the program and check your code in the appropriate menu subroutines within the fmain class file. You can also compare your code to the fmain class file in the description below the video. Remember, typos and omissions are going to happen. However, the good news is that finding and understanding problems really will teach you the most about programming. In fact, many of my best programming learning experiences consisted of being given code that didn't work and my having to examine, parse, and debug the problem. The program examples that I use were all created and tested by me, and are working as demonstrated. So you can make direct use of the examples, but don't hesitate to experiment on your own, take a break, or even use some copy and pasting if you run into a serious problem. If a program is just not operating the way it is supposed to, it is most likely something that was simply mistyped or is missing. Make sure that all of the program code and program element names are present and correctly spelled. If the Gambas IDE itself is producing actual error messages, look them up. They can be very helpful in pointing you in the right direction. This is why I recommend testing the various program elements so frequently. Catching a program issue quickly while it is localized and easily identified makes fixing any such problems much simpler. Once everything is working correctly, we will move on to the next menu item. The next menu to be coded is the View menu. This menu controls two sections of the visual characteristics of the tab experiment program while it is running. First, the menu will allow a user to set whether the program's radio buttons and check boxes are visible or not. The View menu will also allow a user to activate which tab on the program's tab control is the visible and active tab. First, to code the radio button's visibility option when the View menu's exclusive choices menu choice is checked, the program code is going to use an if-then conditional branch to see if the menu checkbox is checked or not each time a user clicks that menu entry. If the exclusive choices menu item checkbox is checked, then the code will set all of the program's radio buttons and the associated label to true, setting the visible property for those program objects. Else, all of the radio button's elements, visible properties, will be set to false. Setting these properties will be done as blocks of code within the if-then statement. The effect will be to hide or unhide all of the radio button elements based upon the status of the menu item's checkbox each time a user clicks this menu entry. Here is the program code that will be executed when a user selects the Exclusive Choices checkbox on the View menu. The code for this menu entry will toggle the visibility of all of the tab program's radio buttons, allowing a user to make the radio buttons visible or not visible. As you can see, the code uses another if-then-else conditional test to choose which code executes when the menu checkbox is toggled by being clicked by a user. The first block of code sets all of the radio buttons to be visible. And the second block of code sets the radio buttons to be not visible. Which code block is executed is determined by the if-then-else construct's logical test. In this code example, if the menu exclusive choices checked property is true, meaning that the menu entry checkbox is checked, then the first block of code is executed, and the radio buttons and their associated label are made visible. Else, the assessment is not true, and the second block of code is executed, setting the radio buttons and the associated label to be not visible. Remember, Gambas basic code syntax specifies that the code for an if-then-else construct is contained between the if and end-if keywords. Also remember, since there is a label on tab 1 which describes the radio buttons as being exclusive choices, for user interface clarity, clicking the exclusive choices entry on the view menu will also make the associated description label visible or not visible along with the radio buttons. To start the exclusive choices view menu entry code block, select the view menu on the main form, then click the exclusive choices menu entry. And in the menu exclusive choices click event, to enter the program code, enter the first line of code for the if-then test. If menu view exclusive choices dot checked equals true, then next, add the line to set the exclusive choices label, label 1, to be visible. Enter label1.visible equals true. Then create the code to set the first radio button, radio button 1, to be visible. Next, after copying the line of code for the first radio button, paste the line into the code block 7 more times. After that, renumber the radio buttons in this code block from 1 through 8. This will create the code for all 8 of the program's radio buttons. Once that is complete, add the else statement. Then simply copy the upper code block, including the label 1 code, and paste it under the else statement. And in this new block of code, change all of the radio button elements' visible properties from true to false. Finally, an if-then-else construct ends with the end-if statement, so verify that this menu option subroutine ends with the end if. And after creation of all of this new code, it would be a good time to save the changes. Finally, you can test this part of the program by running it and checking and unchecking the exclusive choices option on the View menu. Here is the code for the View menu's inclusive choices entry. As you can see, the code is virtually identical to the exclusive choices menu entry code, except that this time the if-then-else conditional code block will set the checkbox elements to be visible if the inclusive choices option is selected on the View menu. Else, the code will set the checkbox elements to be not visible if the inclusive choices option on the View menu is unchecked by a user. Now we will create the View menu inclusive choices code block. Now, to code the View menu's inclusive choices menu checkbox, which will be virtually identical to the exclusive choices code block, again select the View menu on the main form. However, this time click the Inclusive Choices menu entry. And in the Menu Inclusive Choices click event, enter the first line of code for the inclusive choices if-then test. If, open paren, menu underscore view underscore inclusive underscore choices dot checked equals true, close paren, then. Next, add the line to set the inclusive choices label, label2, to be visible. Label2.visible equals true. Then, create the code to set the first checkbox, checkbox 1, to be visible. The code is checkbox1.visible equals true. Next, after copying the line of code for the first checkbox, use pasting to create 5 more lines of code for each of the 6 checkboxes on the Choices tab. And this time, renumber the checkboxes in this code block from 1 through 6. This will create the code for all 6 of the tab program's checkboxes. Once that is complete, again add the else statement. Then simply copy the upper code block, including the label 2 code, and paste it under the else statement. And in this new block of code, change all of the checkbox elements' visible properties from true to false to hide all of the checkbox elements when the Inclusive Choices menu entry is unchecked. Finally, an if-then-else construct ends with the end-if statement, so again verify that this menu option subroutine ends with the end-if. After creating this code block, go ahead and save the changes again and test the Inclusive Choices View Menu entry. Additionally, here is another useful programming tip. In the current version of the program, the label objects which describe the radio buttons and the checkboxes are still currently named Label 1 and Label 2. At this point, you may see why programmers usually change the names of program objects. The practice of using descriptive names for controls and program elements makes the program code more programmer-friendly. To see how useful this can be and how helpful the Gambas IDE is, return to the fmain form. First, to rename the labels on the Choices tab, make sure that you are on tab 1 within the fmain form. And select the Exclusive Choices label on the tab. Then, in the Properties pane, change the label object's name from Label 1 to Exclusive_Choices_Label. Next, select the Inclusive Choices label on the tab. And in the Properties pane, change the label object's name from Label 2 to Inclusive_Choices_Label. Here I have capitalized the word label in the object's names, simply to make the objects themselves more identifiable within the program code. And while there are common coding conventions and coding styles in programming, which I do encourage you to observe and adopt, remember that the most important purposes for such coding practices are to facilitate making the code easier to read and understand, both for you and anyone else that might need to work on the program. Now return to the fmain class file in the IDE. And you will see that Gambas has changed the Label 1 and Label 2 code references to reflect both of the label's new object names. This feature of the IDE makes changing or updating program elements much simpler. As you can see, giving objects descriptive names to make identifying and coding them easier is such an incredibly useful action that facilitating it is actually built into the Gambas programming environment. If possible, it is usually most effective to give program objects descriptive names as you create and employ them, to make the process of programming more efficient. However, as you can see, Gambas makes extending and modifying existing programs relatively easy. Just remember that creating a set of design goals and designing the various elements within a program before you actually start coding will always produce the best results. And also remember that consistency in naming and coding methods is extremely important to make both the processes of programming and maintaining those programs as effective as possible. In fact, to achieve that goal, one method that I would heavily recommend is reviewing other programmers' program code whenever possible. By examining such examples and experimenting with such programming techniques in your own programs, you can discover the most effective techniques for writing programs and learn those commonly used programming conventions. Now, after making these changes to improve programming efficiency, we will move on to finishing the View menu's options to display or select the currently active tab. The next menu item on the View menu is the section of the View menu which uses radio buttons to select the active Tab Panel tab. Or conversely, when a Tab Panel tab is selected by a user, the associated View menu's radio button needs to be set. So this section of the menu system actually has two parts. First is the code to set the correct menu entry radio button on the View menu when a user manually selects a tab by clicking on a specific tab on the Tab Panel control. And the second element is the code which is executed when a user clicks a View menu radio button to switch to a specific tab on the tab control. In this case, as stated before, this program functionality from a purely practical user interface perspective is fundamentally redundant and serves no real purpose. This program functionality exists simply as a programming exercise to demonstrate using a tab control and menu radio buttons. For this example, within the View menu, there are radio buttons for the Choices tab, the Slider tab, the Text tab, the Buttons tab, the Drop-Down tab, and the Picture tab. First, we will create the code that sets the appropriate radio button on the View menu. To do this, we are going to utilize a new element of the Gambas basic language, the Select Case element. Here is the Select Case code, which will be in the Tab Panel Click event. You should note that a Tab Panel's click event is triggered when a user clicks any of the Tab Panel's individual tabs. So the same event code block is executed whenever any tab click occurs. The Select Case code will determine which of the tab control tabs has been selected by a user and set the appropriate view menu radio button based upon that information. This code utilizes a new code decision-making code element, the basic language's select case statement. The select case structure consists of the command and a group of case code blocks which are executed based upon the status of each defined case. The overall structure of a case code block begins with the select case code block command and ends with the end select code block command. Between these opening and closing commands are where each of the case decision elements are defined. Each case block contains the code that will be executed when that particular program condition occurs. First, select case tells Gambas that this is the start of a code block. Gambas will selectively run the individual case code blocks as determined by the different conditions specified within the code. An input variable is specified at the end of the opening of the select case code block, and the input variable determines which of the defined cases is executed. An input variable is passed to the select case code block. In this program example, the input data will be the tab panel's index property, which contains the currently active tab panel tab. Then each case code block is followed by a value or test. If the input variable matches the individual case's specified criteria, then that case's code block is executed. This allows different code blocks of code to be executed based upon the input variable, such as the first case, the second case, the third case, and so on, for any number of conditions that require different actions based upon specific program conditions. In this code block, there will be a different piece of code in each case code block to set the correct view menu radio button when a user selects a tab. Again, the select case construct begins with the select case command, and that command is followed with a variable element which will determine which case code block will be executed based upon the data sent into the select case code block. Since in this example, the variable element sent to this select case code block will be the tab panel's current index property, the individual case code blocks will be triggered when a user selects a tab. Also remember, many software elements in computer numbering systems actually begin with 0 and continue through the list of element index numbers incrementing from 0. This numbering convention does apply to tabs in a tab panel control, and since in this case we have 6 tabs, be aware that the tab indexes are actually numbered from tab 0 through tab 5. So the first tab panel tab has an index number value of 0, and the highest tab number is 5. And therefore, the individual case input variable condition tests will exist for the values 0 through 5. In each case, the appropriate view menu radio button will be set based upon which tab panel tab is the currently selected tab, as indicated by the tab panel's index property. Now I am going to discuss the code in the tab panel's click event, including the new select case code block. The next code section will be the code blocks that are executed when a user clicks one of the tab panel tabs. Remember, first we need to deal with clearing all of the View menu's radio buttons before setting the currently active tab's radio button on the View menu. We need to do this before setting a View menu radio button because, as I explained earlier, one of the characteristics of a menu radio button is that directly setting the checked property through code can override the standard radio button exclusivity characteristic. This quirk of the menu system actually allows a programmer to have greater control over the use of different sets of radio buttons within the same drop-down menu. However, for this example, we simply want our radio buttons to function as a single group of radio buttons. So, to make sure that only one radio button is set at any given time, the first thing that the code in the tab panel's click event will do is clear any previously set radio button. There are multiple ways to manage menu radio buttons. However, this menu option example is very simple, so I am simply going to utilize a very straightforward approach to synchronizing the View menu's status radio buttons to display the currently selected tab. This code will simply clear all of the radio buttons before setting the correct View menu radio button when a user clicks any tab on the tab panel control. The code will directly uncheck each menu radio button regardless of the previous state of the menu radio button, and set up the menu to display which tab panel tab is the currently active tab. The next part of the tab panel click event code block will call the block of code to set the correct View menu radio button. So this is the code section which will use the Gambas language's select case construct to set the correct View menu radio button. Now I will enter the code for this section of the menu system. The new code blocks will be added to the tab panel's click event to synchronize the View menu's radio buttons. So the View menu will indicate which tab is the currently active tab. After returning to the fmain form, right-click Tab Panel 1. Select the click event. Remember, when any of the tabs on the tab panel is selected, in other words, clicked by a user, a tab panel click event is generated. So this code will be triggered by this user event, and the code will set the correct radio button on the View menu when a user selects any tab. First, I am entering code to clear all of the View menu radio buttons for all of the tabs before setting the correct menu radio button. The tab experiment program currently has a Choices tab, a Slider tab, a Text tab, a Buttons tab, a Drop-Down tab, and a Picture tab. And we have already designated each of the View menu object names to begin with the text menu_view_. Then the next part of the menu object name is the actual tab name. In this code, the menu object's name will also be followed by a .checked property, which we will be setting equal to false to clear the radio button. The first line of code, which will clear the first View menu radio button, is menu_view_choices_tab.checked equals false. You have probably noticed by this time that while you are typing, Gambas will automatically provide a pop-up offering the possible program object options based upon what you have typed. This can be very useful in helping you to enter the exact object names and properties, and I am going to use this feature to fill in the program element names that will clear the various radio buttons on the View menu. These are just some quick coding shortcuts that I personally use to more easily write code. However, I recommend that you use whatever computer keyboarding style that is the most comfortable for you. In this case, I am going to use the helpful Gambas IDE pop-up while creating all of the necessary object code entries, along with making use of copying and pasting. First, I am going to copy the first part of the line of code, menu_view, and then paste the line 5 more times to create the lines of code for all 6 of the menu radio buttons, which represent the 6 tabs in the program. At this point, I am going to add the actual tab names to each line of code using the program element pop-up box. I will accomplish this by placing the cursor at the end of each menu item on each line, and then I will add an underscore character to the end of that text item. This will trigger the Gambas IDE text editor pop-up program object suggestions box. This is due to the text editor detecting when the cursor is actively within a program text object, as long as the active text element is part of a valid program object name. So this typing will cause the pop-up assistant to automatically offer the list of possible program objects based upon what has already been typed. Then, after the pop-up appears, I will choose the correct View menu object from the list. I am using this text entry method to speed the process of entering this code. I find this method, along with making liberal use of copying and pasting, to generally be a faster and more accurate method of entering such code statements. Remember, however, while programming, you can use copy and paste, or select elements from the helpful pop-ups, or simply manually type in everything. And you can use any combination of these methods. Again, there is no one correct method to accomplish any programming task, and I recommend that you try out all the various options for creating code text to find the coding style that best suits you. Note, you could even type the code from start to finish within an external text editor outside of the Gambas IDE, and then simply paste it into the Gambas code editing window. The final goal is simply to achieve entering the code text in the easiest and most efficient manner for you. And as you program, over time, you will find the fastest and least error-prone methods for entering your code, based upon your own style, the programming language, the environment, and/or the IDE that you're using. Now I will use these various code entry methods to actually create the lines of code that will uncheck each of the View menu radio buttons. First, I will add the rest of the View menu radio button names for the slider, text, buttons, drop-down, and picture tabs. And finally, I am going to add the .checked equals false to the end of each code line. Next, I will add the Select Case code to the Tab Panel 1 click event, again using the various data entry techniques which I have demonstrated. And now, save the work. You can now test the program to see that the View menu accurately reflects which tab has been selected and is the active tab. The final element for the View menu will set the active tab when a user clicks on a View menu radio button, which activates the specified tab on the tab panel control. I have decided at this point in the project to use a very straightforward approach to coding this functionality. Each of the 6 View menu radio button click events will simply directly set the tab panel's index property, which will immediately make the specified tab the active tab. In other words, the currently open program tab. This will be done with a single line of code, tabpanel1.index equals, followed by a number representing the appropriate tab panel tab, such as the Choices tab being index equals 0, the Slider tab being index equals 1, the Text tab being index equals 2, etc. So returning to the fmain form, click on each of the 6 View menu radio buttons to add a click event subroutine to the class file for each menu item. Remember, you will have to return to the fmain form each time you click a new View menu item to create a new click event code block. Now that the class file contains the code blocks for each menu item, add the line tabpanel1.index equals to each of the View menu radio button click events. And since the View menu radio buttons are organized in the same layout as the actual tabs, it is very easy to finish coding this section. Simply append the numbers 0 through 5 to each of the View menu radio button subroutine lines of code. You can now save and test the program again to see that the View menu and the tabs on the tab control are fully synchronized. As before, manually selecting a tab updates the View menu radio buttons, and now clicking on a View menu radio button also sets the active tab on the tab panel. The final top menu in the Tab Experiment program is the Help menu. The Help menu contains two items. The General Help option, which is currently disabled, and the menu option that provides information about the program's version and authorship. Creating effective help systems for software is an entire area of program design that really warrants its own discussion. Additionally, there are several important Gambas programming techniques and elements which need to be covered by the tutorials before we could effectively code a reasonably useful and complete software help system. so we will leave the full program help system option disabled at this point. Remember though, you could also re-enable the menu option and simply call the option unavailable subroutine at this time. Or you could try your hand at creating your own help menu system at this time. The best advice I can give you is that while expanding your knowledge, it never hurts to just have some fun and try out new things and ideas. Just create a new project from the existing project and experiment with what you have already learned, or look on the internet for useful information and coding suggestions. You might even create the next great help system paradigm. I am constantly amazed and inspired by what motivated people can create. However, at this point, the last menu item which I will code is the help menu's About menu option. Here I am simply going to create a formatted text string to display the final version number and to identify the software developer, i.e. author information. I will display this using a standard pop-up message box. Again, there are more creative and much more elaborate methods for displaying such information, but at this point I am simply going for utility, using the programming methods which we have discussed so far. However, before I code the final menu item, I would like to quickly cover another related programming topic. So now I am going to discuss some fundamental information about software versions and software development phases. I am now going to discuss software versions and development phases. Here is an example of a program's version. Quite honestly, software versioning systems are often very arbitrary and vary significantly between different software developers and communities. Some versioning systems have very specific and detailed metrics or purposes behind them. However, the many systems vary widely, and the fact is that there is no uniformly accepted rules or methods for defining the many different version levels for software. For example, some systems are based upon changes in the actual code base, the degree of changes in the user interface, or modifications to the underlying software's functionality and features. In other systems, the version may simply be based upon the release date of the particular code base or project. Software versioning can even be more a matter of marketing than any accurate measure of underlying software elements. So the purpose of a software's version description can actually serve many different purposes. First and foremost, the version generally identifies the software so that its functionality, requirements, and compatibility can be understood and compared. This version identification may be used primarily by the users, or the developers, or those that are supporting the software, or various combinations of those elements. Some of the most common software versions that are used consist of 2 or 3-digit version identity numbers separated by decimal points. Commercial software most often utilizes a 2-digit version number. In this schema or methodology, the first digit defines the overall identity or general version of the software product. The second digit, separated from the first digit by a period, defines very subtly different versions of essentially the same software. These point versions may include relatively minor improvements or patches to fix problems which have been identified, or both. However, you should be aware that such point versions are sometimes released as an independent product version after the original software product's release. But generally, minor point versions are all essentially the same software as the major version, with the same general functionality and user interface. 3-digit version numbers are more commonly used by open source and/or developer communities. In the 3-digit approach, there is a greater granularity of the software's status, which allows a finer definition of various software functionalities, modifications, and updates. It is important to note that internal versioning, the versioning that is used by the software developers, and external versioning, the versioning that is seen by end users, may be different. For example, some software developers use a combination of version identities and also what are defined as build numbers, along with other methods to track internally the state of their software projects, and then actually release a 2-digit version for end-user purposes. Since open software development usually requires that the latest iteration of the software also be available for further development, open source software generally uses the 3-digit version numbers. Again, however, all of this is highly variable. Just be aware that all software with the same major version number is usually considered to be essentially the same software. Also be aware that the general open source convention is that a major version number less than 1 usually means that the software is still under development and has not been fully finished or tested. The minor version number denotes only minor changes or modifications. And finally, the last of the 3 elements in a 3-digit version number denotes the level of patching or bug fixes that have been implemented since the last major/minor release. This last digit, therefore, allows a quick assessment between the various levels of patching which the core program has undergone. Another characteristic of the 3 elements of this version system within open source software is to allow the assessment of possible risk to a system from upgrading a particular piece of previously installed software. Put simply, the 3 categories of versions, major, minor, and patch, generally also represent a ranking of the possibility of rendering an already installed piece of software unstable or even non-functional. The situation of an update introducing problems or rendering a previously working piece of software non-functional is commonly called breaking the software. This has always been a potential issue for all types of software upgrades. In the 3-digit open source version system, the 3 levels of revision represent the following levels of potential risk. Major revisions represent effectively new versions of a particular piece of software, since by installing a major revision, a previously working version is actually being replaced with a fundamentally new piece of software. The requirements for the software and its compatibility with previous software or environment may not be assured. So a major version upgrade can, in theory, represent the highest level of potential risk of not operating correctly. A minor revision, the second number in the 3-digit system, may add new features and contain different functionality than the previous version. However, it generally contains much of the original codebase's characteristics and any software requirements called dependencies. So a minor revision upgrade poses much less of a risk of failing to function as expected or causing problems. And finally, patches, the last number in the 3-digit system, usually pose the lowest risk of potential consequences from being installed. The major, minor, and patch risk assessment scheme is usually considered a good rule of thumb for end users when making decisions regarding upgrading and maintaining software and system integrity. Here, after talking about how software versions relate to software projects and products, I am going to explain the somewhat arbitrary Tab Experiment Program's version scheme, which I have chosen to use for the help menu's final element, the About menu option. You can use my system or come up with one of your own, depending on how you may have proceeded while utilizing the elements of the Tab Experiment Program tutorials. As I have said, since this software has different purposes and development elements and creation methods, you may have an entirely different production structure, and therefore your versioning for the program may be better represented by different program development milestones. My definitions for the different versions is loosely based upon the different major elements of the Tab experiment program as created during this tutorial series. For the overall version system, I have decided upon using a 2-digit versioning system, since this program doesn't actually have a final target user base or an overly complex development cycle. And realistically, the program will not receive code patches or updates once this program exercise is completed. So I have simply chosen versions based upon some of the fundamental points during the development and creation of the project. The earliest part of the program preceded a fully implemented collection of all of the intended program elements, so I specified the first major version as being less than 1, and merely wished to demonstrate that the basic project had been created and significant work had begun. The next version, version 0.2, included all of the intended Gambas visual controls. However, the necessary coding to make the program elements actually functional had not yet been accomplished, so the major version number is still less than 1. I decided to state that the Tab experiment was initially whole when all of the basic controls were fully implemented and coded, so I decided to call this version 1.0 because the version could be compiled with all the included graphical elements within the program being functional. Version 1.1 included the uncoded menu system as part of the user interface, so the menu system itself was not actually functional at that point. Version 1.2 represented the first version that fully implemented all of the intended program elements and included all of the final elements of the user interface. So after coding the menu system's final functional elements, I have decided upon defining the program's current operational version number at the end of this tutorial, Tutorial 5.6 Part 5, as version 1.2, and that will be the version number that will be displayed by the Help menu's About dialog box. The last element of programming that I am going to quickly cover before I code the last element of the Help menu are the stages or phases of the software development process. The first phase of creating software is the alpha phase of software development. It consists of designing and creating the initial software. Testing of the software is usually done inside of the development programming environment by those writing the software. For example, the Tab program's current state would be the alpha phase of software development, since we are actively designing and creating the software, and we are testing the software while we are coding it inside the Gambas IDE. The beta phase of software development is the point when the design and coding of the overall software is generally finished, though some of the functionality may be incomplete. Testing of such software is done outside of the development programming environment. This testing is performed upon compiled, relatively finished versions of the software. This testing is either done by the expected users in an experimental setting or by people called beta testers, who have chosen to use and evaluate the beta software during development. If problems with the functionality or internal elements of the software are discovered, it is returned to the developers with detailed descriptions of the problems which have been encountered. Finally, when the software is ready for distribution, in other words, all of the functionality has been designed, coded, and tested, and those involved have concluded that all of the critical bugs and problems have been resolved, the release or the fully compiled and vetted version is made available outside of the development environment for general users. In other words, this is the version released to consumers or IT professionals as fully finished software. It should be noted that after the beta version, before the final release version, many software developers have an additional phase called the release candidate. This release candidate stage of the software development life cycle can be thought of as a final beta test phase before the developers commit to an actual full release. This is also where such concerns as user acceptance and final marketing considerations may be fine-tuned. So, with the current version number having been established, I am now going to code the final element of the help menu, the About information pop-up box. This is the About message box which I am creating to display the program information for the Tab Experiment program. The message box will display the program's name, the current version, version 1.2, and the program's authorship information. Again, you should feel completely free to include or change any of this information in your own version of the program. Here is the actual code that will cause the appropriately formatted information to appear in the pop-up message box. Here is the relevant program information contained in text strings, the new line characters to format the vertical spacing for the appearance that I want, and the concatenation characters to tie the text and formatting together. So here is the effective functionality of the complex string which is being passed to the message function for the program's About pop-up message box. It contains all of the information and the formatting in a single text string. Now, I will be entering the code in the program's class file. To code the final enabled menu entry, the About menu entry on the Help menu, again return to the Gambas IDE's program form and select the correct menu element. Now that I have explained how I decided upon version 1.2 as the somewhat arbitrary version number of the current working version of the Tab Experiment program, I will enter the message box code that will display all of the text elements along with the formatting elements to create the appearance that I want for the message box. To accomplish this within the Menu Help About Click subroutine, I will enter the message command and the parameters within the function's parentheses. The complete text string for this example will consist of a new line character string 10 command, then the program's name text, then two character string 10 commands to create my intended vertical spacing, then the version number text, followed by another set of two new line character string 10 commands, and finally the author text string. All of this joined into a single text string using ampersand concatenation characters. This code statement was designed by me to create the appearance that I feel looks best and provides the information that I think is appropriate. But again, I really encourage you to experiment freely and create your own message string and message box layout, designed to look the way you want it to look. After adding this last piece of program code, we can save and test the last functional menu item. That concludes all of the current elements of the Tab Experiment program which we will be creating in this tutorial section, Tutorial 5.6 Part 5. In the next tutorial, Tutorial 5, Section 6, Part 6, we will be adding some additional code to the Tab Experiment program to polish a few of the final elements of the program. These final program element additions are designed to improve the overall effectiveness and general user experience within a program's user interface. After these last changes to the Tab Experiment program, I will be moving on to tutorials which demonstrate Gambas basic language, programming, and code principles, such as a look at computer variables in Gambas Basic, as well as a deeper look at how subroutines work and how to use them in code. I will also be describing some of the fundamentals of adding modules and additional forms to a project. So now that the Gambas IDE and GUI-based programs in general have been covered rather extensively, in the next tutorials I intend to focus more on the actual language elements of Gambas Basic coding. Again, thanks for taking a look at these videos and joining me as I explore the Gambas language and making these videos. I hope you find them useful.